Okay, this is lesson 3.4, rates of change, and this is the second part of this lesson. We will study now the effect of a 1-unit change. If you remember, we learned the formal definition of the derivative says that f prime of x initial equals the difference quotient, the change in h minus f of x initial over h. Remember that? Okay. If we consider that change, that h, it's a unit 1, then if h equals 1, then f prime of that x initial, if it's x initial, it's approximately the same thing as f of x initial plus 1 minus f of x initial. Okay? This is called the approximation of a 1-unit change. So f prime of x initial is approximately equal to the change in f caused by a 1-unit change. So when we increase by 1, this is the equation that we have, and we're going to be using that equation for the problems in this part of the lesson. Okay, let's start by solving the first example, which is example number 3. In example number 3, we have that for speed s between 30 and 75 miles per hour, the stopping distance of an automobile after the brakes are applied is approximately f of s, which is equal to 1.1 s plus 0.05 s squared feet. And for s equals 60 miles per hour, we have to estimate the change in the stopping distance if the speed is increased by 1 mile per hour. So we're going to be using this equation, okay? A 1-unit increase. 1 unit increase. This is the equation. Okay, let's start. We're going to be using the derivative. So f prime of s, we will need the derivative, will be 1.1 plus 0.1 s. Okay, and this is gonna be feet per miles per hour. Once we have that one, my x initial was this one, the 60 miles per hour. So f prime of my x initial, f prime of 60, will be 1.1 plus 0.1 times 60, which equals 7.1 feet per miles per hour, and that's my first answer. Okay, on letter C, well, no, before we go there, on letter C, before we go there, we are going to estimate the change in f, and we're gonna do it. We will find f of 61 to verify my answer, minus f of 60, which is gonna be approximately f prime of 60, remember, and that was 7.1, the answer that we had before, miles per hour. On letter B, you have to compute the estimate with the actual increase in the stopping distance, so the real value. So let's find it. This was letter A, and now letter B. f of 61 minus the real values of f of 60, which is 253.15 what I did, I plug in this 61 and in this equation. That's what I did. Okay, minus f of 60. Again, I plug in this value in the same equation, which is f of 60, 246. And the answer for that is 7.15. So if you compare, well, of course, feet per miles per hour. If you compare this answer with the other one that we got, it's a very good approximation, 7.1 to 7.15, which is the real value. So the 1 unit increase help us calculate that change with an easier formula, because it's always going to be easier to use the derivative. At least we are getting down the powers, so it will be like an easier equation. Let's use the same context of the same formula of the 1 unit change, but in another context. We will use it in economics. This is called the marginal cost in economics. Okay, if C of X, it's the cost of producing any product, X units of any particular product, then let me write down the topic, marginal cost. So we are marginal cost, and that's where we are. And we're going to be using the same idea of the 1 unit increase. So in this case, if the cost of producing any particular product, it's going to be C of X. This is the cost, C of X. Then, if I want to know which is the marginal cost of increasing 1 unit of production, that marginal cost will be C prime of X initial, which will be C of my X initial plus 1 minus C of X initial. Okay, so we're going to be using that to solve or to estimate marginal cost, and let's start by solving example number 4. On example number 4, which is the cost of an air flight, you have the company, a certain company data suggests that the total dollar cost of a certain flight is approximately C of X, which equals 0.0005 x cubed minus 0.38 x squared plus 120x. 120x. Okay, where x is the number of passengers. Letter A, you have to estimate the marginal cost of an additional passenger if the flight already has 150 passengers. So, marginal cost, C prime of 150. You will need to recognize the questions, remember? So first, let's find C prime of X, which equals 3 times 0.015 x cubed minus 0.76 x plus 120. So we will do C prime of 150, which will be 0.0015 times 150 squared minus 0.76 not 26 times 150 plus 120, which equals 39.75, and we are estimating that value using the derivative or the marginal cost. Okay, let's go now and do these are dollars. Okay, this is a price. Letter B. Compare your estimate with the actual cost of an additional passenger. So let's do it in the finding the real value. That will be, it's a 1 unit increase. Remember that when we use the marginal cost, we use X initial, the lower value, okay? So for the real one, it's gonna be C of 151 minus C of 150. And what are we going to be doing? We're going to use this value of 151 and plug it in here, minus this one, plug it in here to find the second value. So in the first one, C of 151 equals 11,177.10 minus 11,137.50, which equals 39.60, which is a pretty good estimation and with a more complex process. Let's go and solve letter C. Is it more expensive to add a passenger when x equals 150 or when x equals 200? In order to see that, we will need to solve C prime of 200. And let's see, plug it in into the equation. 0.0015 times 200 squared minus 0.76 times 200 plus 120, which equals $28, which is less expensive than those 39. So it's more expensive to add a passenger when x equals 150. Okay, we're gonna stop here and do a part 3.